Hi, I'm Gene, and welcome to Masterclass on Math, where we support educators through deep dives into critical topics and issues around mathematics instruction.
We began our whole journey by talking about the potential for there to be a science of math, some type of equivalent to the science of reading. We talked about some of the differences between math and reading, which must be acknowledged, which primarily is the fact that, unlike the reading wars, which are over, there are still ongoing wars about what constitutes high-quality math instruction, and that has implications for us moving forward. And then finally, in the last session, we reviewed the concept, or the four words that I believe are the most important about math, which are that math is ruthlessly cumulative. So in this session, let's sort of bring these ideas all together and talk about the implications for us as educators and how we might move forward. Now, at the end of 2023, Education Week published an article where they were looking into 2024 and theorizing or positing what might be on the horizon in relation to math. One of the things they said is there would be ongoing discussions about what constitutes high quality instruction in math. And the other thing, which is closely related to that idea, is that there will be an ongoing focus on high quality instructional materials with math. Now, we've heard this HQIM, high quality instructional materials conversation in reading, but the problem is, if there's not a clear consensus about what constitutes high quality instruction from the research base, then there will be a corresponding lack of consensus of what constitutes high quality instructional materials. Those two are closely related together. So let's explore this concept of math instructional materials. I would suggest to you that even the most well-structured math curriculum is probably lacking in some areas. Now, before we talk about what might be lacking in a specific curriculum, let's just take a step back for one moment and have a quick discussion about what is learning. Now, that sounds like a very basic question, but an essential one, and I will offer a very basic answer that comes from some of the cognitive scientists that we have been tracking. Primarily among them, Kirshner, Sweller, and Clark. They define learning as a change in long-term memory. Now, at first, when I heard that definition, I thought, well, that's just really simple. Here's what they're talking about, however. A change in long-term memory, not short-term memory. Long-term memory would be something that you could then access at any point going forward. And what Kirshner, Sweller, and Clark were trying to impart to us, the idea that they were trying to get across is, if what we teach kids doesn't get stored in long-term memory so that it can be retrieved, then they haven't learned anything. And often kids store what we teach them in short-term memory. Let me give you a personal example. I vividly remember one morning walking into my high school, and I had health class first period in the morning. We had a quiz that day that I'd forgotten about. And the quiz was on the 15 different steps you take. It was a first aid class. The 15 different steps you take if someone is experiencing frostbite. So I spent some time cramming those ideas. I sat there all throughout the morning in the library and all throughout homeroom, really reviewing all of those ideas. And I made it to first period and I made it to the quiz. And I got an A on the quiz by remembering all 15 things you do for frostbite. But you know what? I'd be hard pressed to tell you more than one or two of those things now. I had them on short-term memory for that class, but clearly I had not transferred them to long-term memory, which means I hadn't really learned them. Now, this idea of how long does it take about working with content to transfer to long-term memory is really, really important. And Daniel Willingham writes specifically about this when he says, he shows that studies that he's reviewed say that when you teach something and you study it, for example, for 6 months or even an entire academic year, if that's the total extent that you study it, retain a lot of it for maybe 6 months or more, but generally speaking, by about 2 to 3 years later, almost all of that is gone. Now, that is if you do not practice it, if you do not keep bringing it up and working on some. In contrast, when individuals spend time with particular subjects and spend working retrieval of those ideas over a period of 2 to 3 years, then something magical happens. After working with things over 2 to 3 years and retrieving them regularly, then what happens is most of that information is retained in our long-term memory to the point that we can remember it 50 years later or more. That's why the title to one article that Daniel Willingham wrote at first didn't make sense to me, because what he said was, we need to practice things beyond the point of perfection. And his whole point is, we can work on something, we can seem to really have a grasp of it, but then we can't just walk away from it. We have to keep coming back to it again, and coming back to it again, and coming back to it again yet after that. Within that article, he makes a powerful statement. He says, the importance of practice cannot be overstated. That's a really important one. The importance of practice cannot be overstated. What he says is, teachers need to think deeply and regularly about the ways that they ask students to practice, how often they ask students to practice, and how they structure it. Now, there are many specific variations that we could take in discussions around practice, but let me just allude to one. There's a growing dialogue about what many folks refer to as retrieval practice, which really closely relates to those ideas from Kirshner, Sweller, Clark, and Willingham about having to work with skills on and off, not over days or weeks, but months or years, to retrieve them enough times that they actually do get successfully transferred to long-term memory. Another way that we used to refer to retrieval practice years ago was to talk about distributed review. And one of the noted researchers in the field, Dylan Williams, says ideal practice for kids would be them practicing something that they learned today, something that they learned last week, last month, last semester, and last year. And by framing that, he's talking about this constant retrieval that we need to do, which facilitates transfer to long-term memory. And Kirshner, Sweller, and Clark are very blunt about this. They say any instructional approach that we use that doesn't account for the necessary retrieval practice that we need is very likely to fail. But I would suggest to you, the one lacking hole in many math curricula is practice. Many programs are silent on how kids are going to practice. In fact, I remember the practice that I went through as a student in school. That was working the odd or even problems in the textbook for a couple of nights. And when we were done with that unit or that chapter, we were done with that unit or chapter, which meant that many times we weren't getting the retrieval practice necessary to really take the concepts that we were learning and transfer them to long-term memory. In fact, this role of practice was specifically mentioned in the National Math Panel report, where they said computer-assisted drill and practice programs should be considered of value because they help students do the necessary rounds of practice that allows them to transfer things to long-term memory and become fluent in the calculations that they are performing. Again, Daniel Willingham's words, the importance of practice is hard to overstate. And Doug Lemoff, who wrote Teach Like a Champion, many of you will know his name. He wrote another book with two other colleagues, Woolway and Yezi. And the book's title is Practice Perfect. Subtitle, 42 Rules About Getting Better at Getting Better. Said differently, 42 different ways that we as educators could think about what we have kids practice and how we have them practice. Now, again, Doug Lemoff and his co-authors, they have 42 different rules. We don't have time for all 42, but let me suggest one thing that I see commonly across the supplementary practice market that's out there. I would suggest to you that the ideal practice solutions would include two options, an adaptive option and a targeted option. Some, or almost all, include an adaptive option, but not all include a targeted option. Let me explain what I'm talking about. When we talk about adaptive practice, that would be a mindset like this. We're going to give the student a pretest, and then based on how they do on the pretest, we're going to place them into our content, And then our system is going to respond to how they do, and it's going to adaptively branch and take them through content, moving them forward. Now, I'm not saying that's not a good thing. It is. Students can work adaptively on their own to build up skills and make their way through content. But what would be lacking in that is the ability to afford within a practice solution targeted practice. The ability for a teacher to say, I want my students to practice this skill because this is the skill that we worked on today, or I want them to practice the prerequisites to something because that's the skill that we're going to work on this week. Teachers need the ability to control, to a degree, practice programs and say, yes, it's fine for you to be adapting part of the time, but at other times I need you to target certain things for me. Again, this idea of kids repeatedly practicing things to the point that they become fluent, and this idea of fluency that we talk about in reading, it carries over to math as well. I remember watching a video done by David Coleman in the early days of the National Math Panel Report and moving into the Common Core work. One of the things he said was, think about the importance of kids developing fluency around certain math skills. He said, when you learn 6 times 7 to a level of fluency, that when somebody says 6 times 7, and instantly your brain says 42. When you learn 6 times 7 to a level of fluency, boy, does it prepare you to encounter in an algebra classroom 6x equals 42. When you have that fluency around 6 times 7 and someone presents 6x equals 42 to you, it's almost as if the answer starts levitating off the page. But sadly, I would suggest to you that in many math curricula, conversations about practice sometimes do not exist. And remember those 4 most important words. Math is ruthlessly cumulative. We must make sure that students learn, transfer to long-term memory the skills that we are teaching. Let's also talk about yet another implication of those 4 important words about the cumulative nature of math. That is that intervening in mathematics is particularly challenging because of its ruthlessly cumulative nature. Here's what I'm talking about. When students miss a skill sometimes along the way, sometimes, particularly as they get older and advance through the grades, the farther they've gone, the harder intervening is. And I'll tell you what, as I was preparing for this session of Masterclass, I had these 2 beliefs that I wanted to validate. First of all, I believe that there were more intervention products out there for reading than there were for math. Secondly, I also believed that there were far more intervention products able to support teachers in elementary school classrooms than there were for secondary teachers. Let me tell you how I found answers to that. I went to the website for the National Center on Intensive Intervention, where they rate both assessments and intervention tools. First thing I did was look at the length of the lists. They've rated over 30 interventions for reading, 20 interventions for math. So my first supposition was true. There are less intervention products for math than there are reading. But then I started filtering by grade levels. What programs can you use in K to 5? What programs can you use in 6 through 8? What programs can you use in 9 through 12? And let me show you what I found. I found that there were 19 intervention products rated for use in elementary school. When you transition from elementary school to middle grades, there were less than half of that. There were only 8 products rated for use with middle school kids. And then when you transition from middle school to high school grades, again, there was less than half of that many. There were only 3 products rated for use with high school kids. And shockingly, several of those 3 products that were rated for use with high school kids suggested that they could be used at any grade level, and I just don't accept that. I don't believe that something you could use with a 3rd grader is going to be just the same thing of what you would use as an 11th grader. So I started thinking about this. Why are there not as many math products when you get into higher grades for kids? Because let's be clear, if there's a market, someone will fill a niche within that market. I don't think that there aren't interventions for middle and high school grades in math because someone just hasn't decided to design them. I think that designing them is the challenge because, again, math is ruthlessly cumulative, which means I could be trying to intervene with a group of, let's say, 10 middle school or high school kids. And within that group, it could be that those 10 kids all need different things because they all fell off of the path somewhere differently along the way. In that sense, it may almost be an impossible task to build an intervention once kids get much older. In fact, here's what I think most teachers do. I think most teachers, particularly those facing the challenges of this in middle grades and high schools, I believe that they do intervention by MacGyver. Many of you will remember that television show MacGyver, where he would just take anything that was lying around and turn it into something. And sadly, that's what I think many middle grades and high school colleagues have to do. They have to look around for anything that they can find to try and cobble it together and make it work for the need that they have, which brings us to one of our last ideas for our masterclass series. That is to meet the challenges that we face, particularly when students have fallen victim to the ruthlessly cumulative nature of math. To meet those challenges, what we're probably going to need to have is not a single curriculum or a single particular intervention product. I believe that teachers are going to need to be equipped with a comprehensive math system of resources. Some practice tools, some intervention tools, some instructional tools, and those things need to all fit together to make it comprehensive. So let me offer an analogy to you. In stark contrast to MacGyver out in the field trying to find anything that's lying around to meet the need, think about how more effective he could have been if he had access to a super well-stocked warehouse where there wasn't just everything that he needed waiting right there, but that it was all perfectly indexed. And that's the type of thing we're working on at Renaissance. All of our resources, all pulled together and all indexed against our learning progression so that when you are working with kids, particularly when you reach into that challenging grades that come later, more advanced in years, whatever need that you find on the part of students, there are resources waiting right there to help you. I believe that to be flexible, we're going to need a wide variety of resources, again, that are well indexed. And if we had that, then we could address the varied needs that our students have. It's bringing us now to really sort of the end of our masterclass series. So if you will, please allow me just one more analogy. We've talked about math being ruthlessly cumulative. We've talked about it being a pathway that we have to lead students on. We've talked about the fact that we don't want them to fall behind and we don't want them to get lost along the way or wander off because, again, math is ruthlessly cumulative and it's waiting out there to cut them down. The other thing that we're talking about is taking students to an incredibly high level of performance. We want to help them make it to high school where they can take advanced math classes and be successful. And not only do we want that, we desperately need that because we need more people to fill the many science, technology, and mathematics jobs that are waiting out there. In that sense, I believe that teachers of math are like Sherpa. Many of you may be familiar with the Sherpa people who live close to Mount Everest. And anybody that's going to climb Mount Everest is going to hire a local guide who will help guide them up the summit and safely back down. And I was looking for information one time because I thought about this idea because, again, teachers, I think, are guides trying to take students to a great height. So I was researching Sherpa out there, and I came across a group called Sherpa Adventures, and they'd written something, and I thought, well, that's really interesting. And I think a lot of what they'd written could be restated for teachers. So let me tell you what they said. They said that every climber in his heart is grateful to have had his Sherpa companion along the summit or trying to make it up through the treacherous slopes because it was the Sherpa who had taken the time to plot the route, carry the load, and lay out the safety ropes going up and back down. And I thought that sounds like teachers. Because you see, I think every learner, every student along the way is grateful to have a teacher who decided what the skills were and the objectives were and wrote the lesson plans and took the papers home to grade and did all the work necessary to guide students forward to higher heights. Back again to the words of Sherpa Adventures. They said, These Sherpa, they risk their lives for a very small fee, a little pittance, taking travelers up these treacherous slopes, and they rarely receive all the glory of a successful summit. And again, I think that sounds like teachers who give their lives for a relatively pittance of salary, make their way through all the educational reforms, and they too also rarely get all the recognition that follows a successful summit on the part of their students. In that sense, again, I think the teachers are Sherpa, taking students along that journey. And we certainly hope that our conversations throughout the course of Masterclass have helped all of you as teachers, as Sherpa, to better understand the journey you need to lead students through and how to successfully get them to where they are going. Thank you.